We learned about simple linear regression helping us to describe the relationship between two quantitative variables, x and y. Before we move on to the next topic, I want to say a few caution when you're using linear regression. In particular, the extrapolation and causation. The first example is reading score of a fourth grader. For every 2 weeks or so, elementary school students are taking a STAR test. They read a book and answer some comprehension questions. Um, by the beginning of the October, this particular student took 3 STAR tests and school sent a report to home. And this is the actual report that taken a picture of. The report includes test scores. As you can see, there are 3 points here. The first um, STAR test, the student got about 900, and then second one a little bit above, and then third one a little bit below 900. The report also includes 25th percentile, 50th percentile, and 75th percentile for fourth graders in general. For example, in the beginning of the semester, the fourth graders will generally goes from 350 to 550, and at the end of the academic year, June, you will see the score is about 4 to 600. And it kind of makes sense that as the whole year, their reading ability is improving. Obviously, this particular student is a great reader. Her score is 900-ish as a fourth grader. Um, then what they did is using these 3 data points, they fit the linear regression line, just like we discussed in chapter 4. And what happened? The regression line that we fit has a negative relationship because it actually has a little bit of downward trend. But this linear regression line are showing that by the end of the fourth grader, she will not be able to read at all. Her test score will be almost 0. So what's up with this graph? Do you think this is a reasonable prediction for this particular student's reading ability? Well, probably not, because if the fourth grader who can be a good reader, not really all of a sudden, well, I mean, because her score, a couple score was low, that doesn't probably necessarily mean that she won't be able to read at the end of the year. So what's happening with this analysis, this linear regression line? First, the linear regression line is based on only 3 data points, right? 1, 2, 3. Thus, it was seriously affected. The fact that her third test score right here is slightly lower than her first 2 scores. And then it predicts the score downward relationship. So more interestingly, they really extrapolated, which means they went really far away, far from where the data set is, and extrapolate the prediction long after what happened actually to the data points. It is often inaccurate to extrapolate and predict far away from the range of the data because it's not really getting accurate. Here is another important caution. Um, this graph, this particular graph is not necessarily, well, it's a linear regression line with the time, but this is not exactly what we want to talk about. But we want to imagine the regression line between the number of autism and organic food sales. The graph shows that both the purple one, the number of autism, and the pink one, the organic food sales, are increasing as time goes on. Arguably, whether there are more autistic kids or we have actually better at diagnosing autism is a different issue. So that's not what we are actually talking about and trying to argue here. But the fact that is the data actually show the increasing trend. So what we're trying to think about here is what would happen we run linear regression between the number of autism and the organic food sales. What we're going to see is we are going to see a very strong positive relationship because they are all kind of these pairs are higher values and these pairs are lower values. And if you actually do the linear regression, it will show very strong positive relationship. How can you interpret the strong positive relationship between the number of autism uh, and organic food sale? To make a long story short, you can say there is a strong positive association, but you cannot say that the increase of the organic food sale causes the increase in a number of the autism. Or the other way, the increase in autism case causes the increase in the organic food sale. So the linear relationship we can talk about, in linear relationship, we can talk about an association, but this doesn't necessarily means causation. Often some other third variable is actually causing the increase in both of the variable. And it's probably what's happening in this autism and the organic sales as well.